Welcome. We're going to do the tortoise and the hare race, and you can see when you looked at this, the equation is d equals t squared for the hare, which is quadratic, and for the tortoise, d equals 2 to the t, and that's for the tortoise, and so that is exponential. So really this is about which accelerates faster, the quadratic or exponential, and you can look at really big numbers to determine that too. So first question, what time does the hare catch up? Well, one way is to make a table and look at when the values are the same, but alternatively you could just set the two expressions equal to each other. So we have the hare, t squared, and the tortoise, 2 to the t. Well, if t equals 2 seconds, we'd have 2 squared is equal to 2 squared. Another possibility, though, is what if t is equal to 4 seconds? And then you have 2 to the 4th, and that is equal to 4 squared. So it actually happens twice. And I tried to show that in the graph here at 2, 4, and 4, 16. It's only because you're squaring and your exponential uses 2 that you end up with these two points where they cross paths. If it's really long, who wins? Well, you can kind of see it on the graph here. The tortoise wins out over the long time. At what times were they tied? We already answered that question. Here and here. Okay, and that's what time they're tied. If it's 15, who wins? Well, exponential is going to win for sure, so that's tortoise. So another way is to look at speeds, and speed is just distance over time, over an interval, since we're not in calculus. So distance over time, meters per second, we look at the distance from 0 to 2. We notice that both of them are at 4 here, right? So for the tortoise, who started with a distance of 1, 4 minus 1, so that's distance. And then the time, the interval is from 0 to 2, so 2 minus 0. Here you get 3/2 meters per second. The hare started at the origin and went up to the 4. So the hare one is a little bit different. It's going to be 4 minus 0 over the same time interval. So it's going to be 2 meters per second. And so right now, that hare is faster, right? It comes off the starting line faster and actually catches up at 2 seconds. Then it's interesting, on the 2 to 4 interval, we notice that both animals at 4 seconds are tied again. So in this case, the speeds should be the same. 16 minus 4 is distance, and 4 minus 2 is time. And so we get 12 halves, or 6 on average over that interval. They're 6 meters per second. It's not linear. They're not always going that. It's varying. But if you had to average that, you would say that, and you would say the same thing, because even though the curve is different, the starting point and the ending point is the same. So on the average, their speeds were the same, even though it was a little bit different in that here the hare starts out a little bit faster, tails off, and the tortoise starts out a little bit slower and then catches up. So here it's a tie. And then this one you're not going to be able to calculate with the infinity. So what you're going to do is try some big numbers. Like you could even try 10, right? And that might be one way to go. Yeah, why not? 2 to the 10th. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So 1024 minus 16, and I think that's 108, 1008, right? And then the time, 10 to 4, well, 10 minus 4 is 6. And then I'm comparing that, shoot, let's get this thing out here. There we go. And then I'm comparing that to the t squared, so that's only 100, right? And I'm still subtracting the 16, and I've still got the same interval, and you can see it's quite a difference here, where we've got 84 over 6. Okay, so clearly the winner in the long run is the tortoise, and therefore over time the exponential is going to grow faster than the quadratic. And I think that's it.